Assalamu alaikum, ladies and gentlemen. Welcome back to another live stream. So in this live stream, we're gonna be coaching Behrus on some C++, SDL, and Vulkan, pretty much. And say hi, Behrus.
Hey guys.
Alright, let's get into it. I think let me copy the video URL. Live. Let's go here. Okay. I think we've done it. Alright. So, where do we start?
Okay, I guess let's start from setting up the
I have other
development environment.
IDEs. I don't work with VS Code anymore, so I'm gonna download it again. And then I can start pretty much. Okay.
Yeah, I was thinking that VS Code has that live share.
Yeah. It's fine. It's like you can stream if you're comfortable with another IDE. Like for me, I use JetBrains IDEs.
Oh yeah.
They're just so good. Let me grab the chat. I forgot. Okay, about the chat. Can you confirm that the stream is fine? It's been a while since I streamed.
Yeah.
Like the sound and.
Yeah, the sound and the video is all good.
Great. Okay. Alright, let's see what we got here. Okay, can you share with me the link?
Yeah. Here you go.
I opened it up online. Visual Studio Code. Okay, there you go. Sign in with VS.
Yeah, you can continue as anonymous, so that should be fine.
Okay, I joined the collaboration session.
Okay.
Nah, it's still joining. Where's the chat again? Let's see. There you go. Okay, cool. I'm not sure what's taking. Oh, waiting for host approval.
I'll wait. I don't see the approvals. Let me share it again. Maybe something wrong.
Okay.
I mean, the URL changed, so.
Alright. Let's try again then. Come on. There you go. Continue as anonymous. What about now?
Okay, there we go. Steps read and write.
Okay, perfect. Alright, so they can start.
So, well, first of all, I was thinking that we need the. So we need a CMake list.
Yeah. Oops.
Okay. Good one.
Okay, so what you gonna start with?
So CMake list. Oh, let's with CMake. Anyone? There. 3.8. Version 3.8. And let's call the project. What do we call the project? Oh, I put that folder name as 2D engine.
Yeah, call it whatever you want.
2D engine. Using C and C6. And that. C6. First down. R. And D. Thanks. Where on okay, so far yeah, so far things good.
Okay.
So I am thinking we need the Git submodule. Was it SDL submodule on Vulkan?
It's just you're gonna use Git submodules, okay.
Yeah. No. There's SDL. SDL.
Okay, are you typing in the shared terminal?
I'm not typing yet. I'm finding
I
the
see.
SDL
Website, okay.
GitHub. Okay. And
Hey Theo Paris, how's it going?
sub.
Welcome to the stream. Submodule add SDL, yeah.
Okay. And the path would be, let's go under vendor, or is it, does it put it itself?
Put it wherever you'd like, honestly. It's just a preference, I think.
Let's put it under vendor slash SDL. SDL. Oh, that's double T.
Yeah.
Not to get repository on any parent directory.
Hello, Beer and Moose. Welcome to live stream. How's it going? What's up, everybody?
Oh. What am I doing wrong? Why am I not able to add the SDL thing?
Because you haven't made this folder a Git directory. It's like you have Git init, yeah.
Oh, yeah.
Perfect.
Okay.
Now it would work.
There we go. I usually don't use CLI to
Yeah, me too. It's like
set it
JetBrains
up.
IDEs just do everything for
Yeah.
me.
Okay, now we need Vulkan headers.
Vulkan headers, you can get them from, you know, the repo. Their repo. Like you can just
Found
get
it.
the SDK and use that, but I
No, I like
personally,
to.
yeah.
I like to have
So
the.
yeah, just look for Vulkan headers, git,
There
and
we
you'll
go.
find the repo.
And slash Vulkan.
So yeah, and here inside of include, you're gonna find Vulkan / Vulkan.h and even HPP and all that other
Yeah,
stuff. So
that is good because you can like literally go through. Because I was having problem. Like I started another project with Vulkan headers,
yeah,
and I
it
was
wasn't
having
there.
problem.
Yeah, exactly.
Yeah,
So
and
the
then like
project wasn't self-contained to some degree.
yeah, so it's nicer to have the code there and like be able to. Okay, so now I'm thinking we need to add this directory, add the subdirectory. What there? Okay. Yeah. Okay. So that's CMake. Now we need CMake presets. Uh,
Can we just ignore the cross-platform aspect of it though? For now at least?
yeah.
Because that would make everything much hairier.
Yeah.
Yeah,
I mean,
alright.
for Windows, we at least need something for
Yeah,
the
just focus on Windows right now.
yeah. Okay. CMake presets. So I do have a pre-made one. I'm just gonna copy and paste here.
Okay.
Okay. The binary is okay. It's built. Okay, so we need to make another folder. SRC. And shall also add this here. Add subdirectory SRC.
You added the SRC in vendor.
Oh, you added the vendor. Ah. Oh, I added the vendor.
There.
Okay, there we go.
Alright.
So, yeah, file. Let's call it main.cpp. And let's see.
Maybe use the latest C++ so I can give you some tips on the latest one.
Well, here's the thing.
If I see an
A
opportunity.
latest C++, if I use C++23
Yeah.
in the CMake list, there's an issue.
I do remember that graph, I see. But
Yeah,
try again, see if it
yeah.
works.
3, let's see.
It works though perfectly in Visual Studio anyways. Okay.
Yeah, the thing is that Vulkan, it doesn't build the Vulkan
I mean, it's not
for
supposed
some
to, it's
reason.
just headers. How do you build this in Visual
Oh,
Studio Code?
I use the presets with Ninja.
I'm not sure why it's not showing it up to me here. I mean, I
Wait, can you
think
not
it's
see the CMake preset, JSON?
I think it's supposed to give me some options from the CMake presets since I have the CMake extension, right?
Yeah.
But it's not. Maybe I have to restart.
Maybe. Do you need another link or? is the other link still works.
I think I could use the other link. Okay, let me try to restart Visual Studio Code and see if that helps. Okay. All right, let's try. Usually I have the CMake tool extension, not sure if it's needed or not. Yeah, that's what I'm using. Code of Chaco. Okay, waiting for host approval.
There you go.
Joined. It's still not showing me the drop down of CMake. Interesting. I'm not sure what's up with Visual Studio Code. Anyways, so what can you share, by the way, the screen?
Yeah. Do you see my screen?
Oh yeah. Alright, so when you build, what happens? Yeah, it's supposed to give me that drop down menu. But it's not. Anyways, configure failed. So what is the no CMake compiler?
Interesting.
I mean, yeah, actually you have that wrong, I think. It's probably like, first of all, I don't think I use the quotes. Maybe? Or do I? I don't remember, honestly. And I think here it's probably language, if I remember.
Oh.
Haven't. Let's see, hold on. So CMake project, because it's supposed to give you like infer the compiler from the language, right? So project name, language name. So it's languages. Oh yeah, okay. What about this? Okay, so that seems good, I guess. The source directory. Well, this is not vendor. Actually, hold on. What? The source directory does not contain. Yeah. So to use add subdirectory, you have to contain, you know, a CMake list.
But I see.
Doesn't, right? So
okay, it's because
one
it's
way
the...
I was doing it is to put like a CMake list inside vendor, which have like a vendor target, and then you would link to that, and it would be just like an interface, right?
Yeah.
So you would handle all your vendor stuff in one CMake list. Otherwise, you could just do everything here. So
well, I'm guessing here if I just put SDL and do another subdirectory.
And for Vulkan, it doesn't have a CMake. Actually, it does, yeah.
It does, yeah.
Yeah, my bad. Never mind.
Okay.
All right, cool.
It's building up.
So to keep it simple, yeah, you could go that way. So we do it that way to like for modularity, so every directory manages its own self to some degree, but yeah.
Okay, what does it say? Does not contain a CMake list. Oh, yeah, the source needs a CMake list as well.
Why you're doing add directory source? No, you don't want that. So right now you have to make a target, an executable target.
Yeah.
Yeah. So no need for this. Just remove it and say, you know, is it add target? I think. Oh, sorry. Add
That's
executable. Fine. Yeah, go.
Is it underscore target?
Honestly, haven't touched CMake in a while. I was using Visual Studio, so.
Oh, add executable. Okay.
Yeah, add executable. Yeah, there you go. Yeah.
The sign project name, and then that would be src
This is basically a
main.
substitution for the variable project name, which would resolve in this case to 2D engine.
Yeah.
So.
Yeah.
Okay, src/main.cpp. Okay, cool. Though you could do add subdirectory src as you did, but you'd have to make a CMake list here.
Yeah.
Where you're gonna include these files and stuff, and you're gonna link to that target. Well, whichever. Anyways, so okay, cool. Now, all right, can you compile that or build that?
It's built. Yeah.
Cool, lovely.
Yeah.
All right, so one tip though for modern CMake practices is target. Oh yeah, set target properties. Okay, so instead of saying CMake CXS standard 23, do you share the live share for viewers, Beer and Moose? Not really. There's no need though. Or is it? I guess.
Is there something that they don't see? I mean, I'm checking.
Just let me know. So instead of setting the properties like globally, you can actually just say set target properties, and basically you can set properties for a specific target.
So you can put for example, for SRC different.
Exactly. Though I don't remember. Oh crap. Hold on a second. Don't remember how to use this. And VS Code is not even helping. Okay, targets, and then the properties. So you give it the targets, then properties, just like this. And then you say, hold on, what are the properties? There you go. Here are the properties. Standard? Yeah, there you go. Well, CXX standard, okay. There you go. Okay, so these are all the properties, like there is CXX standard here, and then you can set it to 23, and then CXX standard required. If you want this to be required, so like the configuration would fail, I think, or the build, I don't remember. But like you would just say true or on.
Okay.
So basically you have all the targets here, and then you have properties, and every property is like, tuples. So like this is the name of the property and the value, the name of the property and then the value.
I see.
But yeah. Okay, try to build this. Hold on, let me remove this. We don't need it anymore, I think. Okay, try.
Yep, built.
Okay, cool. Alright, so where should we start?
So I was thinking of because so far I've gotten a window in Vulkan.
Okay.
But aside from
let's start by initializing. Actually, I forgot that we have to set up the libraries. So, but yeah, start by SDL init. Yeah.
SDL init.
Yeah.
What was it? Well, don't we need? I was setting up
SDL init, SDL video, I think, or SDL everything.
Yeah. SDL init everything?
No, afterwards, yeah. So it's flags here, so like what subsystems you wanna initialize. No, here inside of here. Okay, go on. SDL. I think it was init everything. You gotta check the SDL documentation.
Yeah, the documentation for SDLs.
But SDL3, the documentation SDL3. So API by category, then initialization is shut down, and there you go, SDL init. And then there is SDL init flags. So SDL init, you could go with, oh, there is no SDL init everything anymore, I think. Weird, interesting.
Yeah,
So
this is exactly the thing I was talking about, is that every time I'm trying to like do something,
there
they
is
break something.
actually, there you'll find, if you go to GitHub SDL, you'll find a migration
Yeah.
guide, and there you'll find
Yeah,
all the
yeah.
changes. I haven't read it yet, but like if that's a problem, there you go. So where is
Yeah.
the migration guide again? Is it called this? Yeah, check out the migration at the guide at docs readme migration. So docs
Yeah, yeah, yeah.
readme migration. There you go. So yeah, and here they would basically mention all the changes that have been done from SDL2 to SDL3. So
Yeah.
I'll find everything here. But anyways, let's just go ahead and do it, I guess. SDL. I mean, it's not an SDL class. Are you sure this would work? I don't think so. Oh, you're gonna make a class?
That's what I was thinking.
There's no need, honestly. If we make classes, it's gonna be crazy, you know? It's
Oh,
gonna
okay.
take a tons of time.
Okay.
So let's not overcomplicate things. Let's keep it simple.
Okay, so
Say SDL
SDL
init.
and then there is the SDL init video.
Yeah, so one thing that I always, even as an experienced developer, I always fall in the trap, which is like just overcomplicating things from the start. So
Yeah.
yeah. Anyways, SDL and SDL. Okay, so if you build this, of course this wouldn't work, right?
Oh yeah, this would. Yeah, I need to
Because
call
we
the
haven't.
SDL.
No, because we haven't included the SDL library. No, remove that.
Oh, you don't need that.
So you need to add it to CMake to add SDL, basically.
Well, isn't adding it to the CMake list as part of the vendor add subdirectory wouldn't work?
That would add the CMake of SDL, but it wouldn't link the executable target that you have made to it. So you have to link it.
I see.
So target link libraries. And
yeah.
in fact, the target in CMake, like when you link something, it's not just, you know, the linking that we know for C++, but linking in CMake, it's kind of confusing. It's actually also including all the other stuff that comes with the target, you know. It's not just linking, you know, in the vanilla sense, so. Alright, target link libraries, private vendor slash SDL. No, not vendor slash SDL. You're gonna check for the name of the target, and then you would use that. I think for SDL, if I remember, it was probably SDL3. SDL3, I could be wrong though, and for Vulkan, I think it was probably like this. So you just gotta check the CMake and look for the name. I'm not sure if there's an easier way. What is the extension of VS Code that shows the compiler error in the line? It's Erlends. It's very, very useful. Though I don't use VS Code honestly anymore. I just use JetBrains products. But there you go, Erlends. It's very useful, so you don't waste time basically hovering over things. So, but yeah, there you go. Okay, try and see if this works by any chance.
I'm getting an error saying SDL init unidentified.
But no, like you have to configure the CMake. How do you do that in VS Code again?
That is it. That is usually what I done.
It's still configuring project down there, no? It's saying in the status configuring project, saving open. Down there. There you go.
Oh yeah, this.
CMake, yeah, it's still saving open files.
Okay, let's
I'm
cancel.
not sure why it's not showing up for me, honestly. Maybe it's because of the live share. Maybe. Yeah, some extensions doesn't work through live share. Well, anyway. So, okay. So what's up now? Okay, try to build again, maybe?
Sure. Still has the
But like, it needs to show you the CMake errors, man. Maybe say Control-Shift-P and then like configure, like of course open first the CMake list. Okay, it's fine. Anyway, configure, CMake configure. There you go. Okay, there you go. So it's configuring SDL, as you can see. That's coming up from you know, it's like SDL's CMake file.
Oh yeah, sure. Okay. So
go down
build.
below, keep it. Want to see what's gonna happen there. Where was it?
Okay, let me just run it again. CMake configure there. I think that's the end of it.
Ah, I see, because we only have SDL. Okay, try build now. Well then, what the heck? It's not giving any errors. Alaikum salam, whoa, G Gear, and welcome to the live stream. How's it going? Alright.
Do we need to?
The problem is
Because
I don't have any autocomplete on my side. Do you?
No, other than that now. The only issue it's showing me is that do we need to add source, target source as well?
Dude, include the SDL.
Oh. Oh wow.
Okay.
Jesus. Include SDL. SDL3. SDLH.
Man, VS Code is very primitive.
SDL3.
It's probably SDL/SDL.
Yeah, I
would
think
guess.
so. Nope. Is this
man.
including?
VS Code is very useless. Can you use Visual Studio instead, maybe?
Visual Studio, I don't know if I have that configured.
Wait,
I can try to configure that.
This is gonna give us a hard time.
SDLH. Nope. Okay, well we can try Visual Studio. Studio 2022.
Alright. Okay.
Project. Oh.
Try. So someone said try include SDL.h.
Include SDL.h.
Yeah. Okay.
Nope.
Yeah, it's like, man, VS Code doesn't even help with this. So, you don't have JetBrains IDEs, no?
No, I don't.
Okay.
SDL.h.
Though, like, maybe we can configure team. What is it called? Like remote control?
Yeah?
like on my own IDE. So
Yeah, we can try that. Yeah.
okay, let's go. I guess. Which software should we try?
I don't mind.
Hmm?
I don't mind. I don't have. Oh, there's
So you could use my own IDE. So
there's something called Quick Assist. It's built into Windows.
I don't remember what it's called. Team. Team Viewer. So there's Team Viewer and there's another one too. I mean, we could go with
Yeah,
Team
but
Viewer, I guess.
TeamViewer is paid. Like try
Ah, I
Quick
see.
Assist.
There was
It's
another
built
one
into
though.
Windows.
There was
The
another.
one that I just
AnyDisk.
sent
What about
you.
AnyDisk? I think this one is fine. No?
Yeah, I mean, like there is one built into Windows.
Oh, I
Yeah,
never used that. You
yeah,
know
it's
how to
just
use it?
yeah. Like I've used it a lot. I can use any desk as well, but
Okay, so how to
yeah,
do that?
just search for Quick Assist. There.
Let someone you trust view your screen take control of your PC. So you need some security code from assistant.
Okay, so are you connecting to my PC or am I connecting to yours?
You're connecting to mine, so you can use my own IDE.
Okay, so then
Though don't tell me the code in stream until
yeah.
I remove the screen share.
Well, I'm sending it to you in Discord.
I can activate the filter.
Yeah, I mean to be honest, the code doesn't really matter because it only
Can you
lasts
hear the
like 10
doggo
seconds.
now, Theo?
Yeah, yeah.
No, what about
No,
now?
it's
I
gone now.
mean, okay, so
It's
I
gone now.
activated the NVIDIA RTX voice. So
Nice.
I knew that was coming. So like the morning, you know.
Yeah.
Alrighty. Okay.
I sent you a code on Discord.
Okay, hold on. Let me remove the screen share. So I think if this code get leaked, we're done, right?
Yeah.
Okay, so I've done that. It's connecting
Yeah. And then it should ask you, do you want to allow this person to connect to your PC?
to your screen. Okay.
Okay, now
Okay,
I can
screen
see your
sharing is
PC.
on. All right. You can remove the code from the Discord chat.
Yeah, sure.
Okay, now I can bring it back. Okay, so is the screen on right now?
Yep.
Cool. All right, so you can actually now try to control.
I have to request access.
Ah, I see. Allow. What about
Okay.
now?
Now,
Okay,
now I
perfect.
can control it.
Okay, look for what is it called? Uh, C line.
The line?
Yeah.
I can't open your task manager.
Oh,
Ah, yeah,
interesting.
there we go. Yeah, because it was
There you
hidden.
go. Is it responsive?
Yeah, it's pretty good.
All right, perfect. Because like if we keep on with Visual Studio Code, it's like we're gonna stay there forever just with Visual Studio Code.
Yeah.
No, Visual Studio is not bad too. Okay, I think it's hold on. Let me take control. Okay, there you go. Go on.
I think it's there.
All right, cool.
Okay. I'm guessing we need a new project.
Yeah, close project. Yeah, that's fine, sure. There we go. Okay, new
Okay.
project. So
C++ executable.
yeah, and language standard C plus 23 or 26. So yeah, it's fine. Go on. Go on, something. Is the voice fine now?
Yeah.
Okay, cool. So, all right. Do automatically in Microsoft Defender configuration.
Oh.
Perfect. And let me click yes. Okay, good. I prefer this way, this layout, honestly. You
Yeah,
know
that's
why?
fine.
So like every time I resize this, the code doesn't
Oh, yeah.
change position, you see. So
That's
like
true.
my mind keeps focused, but yeah, whatever. Anyways, so all right, so you have the CMake list here. So it's already configured a bit, but let me just retype the things that we've done already.
Yeah, sure.
So of course, get init, or in VS Code you could, I mean, in JetBrains CLine,
Yeah.
you could just say create get repository. Okay, there you go. Now I can make a folder. I could call it, I don't know, system modules, I guess. Then I can go inside of submodules, and then we can get submodule add. Let's look for git. Oopsies, SDL git. There you go. Get submodule add this, and there's Vulkan headers here, and then I can copy this too. Though, by the way, if you wanna like a specific version of the SDK,
Yeah.
you can actually go to one of these branches. So, yeah. But I'm just gonna go with the master anyways. Doesn't matter. Get some module add. And there you go. We added the submodules. Okay. Now add sub module. Well, sub directory, right? And
Yeah.
then we're gonna say project name. Well, what I'm doing, my bad. Let's go to submodule / SDL. And Vulkan dash headers. And then we're gonna target link libraries. You see how helpful is a good IDE? It's autocompletes for me and everything. So project name, private SDL. You see, it even tells me the targets.
Yeah.
There you go. This is actually new. It wasn't there. That's cool. Lovely.
Okay, that's nice.
And okay, what's next? The other thing that I told you, you can actually remove this globally and apply it locally. So target, target, what is it called? Targets. Yeah, so target properties, and then project name, properties, CXX standard 23, CXX standard, standard required on And you could just click on this button to reconfigure CMake. And there you go. Right now, SDL is being configured.
Nice.
And this is, I think, where we've left it before.
Yeah.
So now just wait for it to... In Visual Studio Code, it didn't do this checking, this testing. That's what I
It
was
did.
expecting. It did?
Yeah. I guess because I've done that before, it didn't take as long.
I mean, it always does it in a new project. Anyways. Okay, so the configuring is done. Now you could try SDL init. Go on.
Yeah. SDL. Oh, nice.
There you go.
It gives you all of the options.
That just
Okay.
these are the flags, I think.
Yeah. And this would be SDL init
In
video.
big init, right? Constant.
Oh yeah.
I mean, the whole thing. There you go. Okay.
Yeah.
There you go. And it already
Oh
included
damn.
for you that, but yeah,
Ah.
just include SDL.h directly. So it basically included the thing that you only need here, but
Yeah.
no. Keep as it was. Like just say SDL3. There you go. Slash SDL. There you go.
Okay.
Okay, cool. And then semicolon there.
Yeah.
Did they change SDL init or something? What? Weird. Why this guy's...
Oh, maybe it's because it's not capital.
No. Or is
There
it?
we go.
Oh yeah, it
Yeah.
is.
Mhm.
Okay, cool. Try now to build this. Okay, now it's building SDL, and you see, the IDE
Yeah.
is very important, man. Like,
Yeah.
there you go. That's done. Build
Cool.
finished. Try to run it. You may run into an
I mean,
issue. There you go. Process finished to exit.
there's nothing to run.
So it crashed unexpectedly. Try to use debug instead.
uh,
There you go.
yeah.
Process finished. Well, it's not helpful. But you know, it crashed because it couldn't find, like, it couldn't link to SDL as a link, as a dynamic library, you know. Now there's two ways of
Yeah.
fixing this. Hold on. You can either link to the SDL3 static version, so static version of SDL. Let me see. There you go, like this.
Yeah.
And I think this would work. Try this. Or you could fix the... Hold on, what? Was not found. Yeah, no, I think it's not... Hold on. Let me give me control.
Maybe.
So there is some variables in SDL. So if you actually go to here and to settings, at least in my IDE, and you go to, where is it called? CMake? Yeah, there you go. So in my case, I have all CMake options. Oh, oopsies, not that. Where is it? Cache variables. Yeah, there you go. So here I could see all the CMake variables
Yeah.
that is in my project, including the SDL ones, as you can see here.
Yeah. Oh
And
yeah, it's the target build library.
yeah, and one of the things there are, where's it called? I don't remember the name, honestly.
How
SDL
you can set it
static.
up
You
inside.
can, maybe we can
Oh yeah.
basically make this static. Okay, let's see now, because before, but let me make sure to, or it's fine anyway, never mind. Let's see now if this would work. Should be linking it statically. Though you can make it work dynamically by doing something else that I'm going to show. But let's try linking statically first. And this really pissed me off at first. So especially that errors, like it took me a long time to figure out how to fix it. Especially the linked version. So
Also possible target include directories.
I hate these tests. Oh my god.
I
Takes a
think there
long
is a
time.
way to disable them.
2D engine. Oopsies, hold on. SDL 3. Please don't tell me you're gonna do it again. Oh no, it's fine, I guess.
Yeah.
Let's see now. Nah. So I think maybe it have to be static. So you got a link to the static version. Try. Now it's building again. So it's probably building the static version now. So before we configured that CMake variable, it was like saying that the target didn't exist. There you go. Process finished it. So now we have linked SDL statically. So you
Yeah.
don't need to include the SDL dynamic library anymore. Though if you want to make it work dynamically, you could do like this. You just have to fix the path. And I don't even remember how did I do it though.
I think it's set CMake runtime output directory.
Exactly, yeah. Set
Yeah.
CMake runtime. Oh.
It's in a bracket. Set open bracket.
Why it's not? What?
Wait, just give me a sec.
Okay.
I think it's this.
Ah, yeah, my bad.
CMake. Yeah.
I forgot.
Underscore
Runtime output
runtime.
directory, yeah. Exactly.
Output directory, and then that would be. Wait. Ah, okay. Your keyboard is in American English.
Yeah.
CMake.
Is it that different from
Current
the
line.
UK?
It's just the semicolon
Ah, I
position.
see. The most important key.
Line. And
I don't
then
think you want
this is
quotes
very
there.
usual. Yeah.
I don't think it would work like with the variables, you know. So it would just be literal, I guess.
Right.
But anyway. I don't know if that's all enough. Try now the linked version, okay. Well, hold on.
I
STL
think just a
3
steal.
shared. Or yeah, we could go just with STL 3 as long as the variable doesn't change. So try now. Or we
Yeah.
could like check to see if SDL is shared or not, and depending on that, we do the other configuration. But anyways,
There we go.
okay, it works already. Weird. Okay, go on. Now you have finally initialized SDL. Congrats. All right,
Thanks. Okay.
so
Thanks for
let's make a
watching,
window.
guys. See you later.
Let's make a window.
Thanks for coming to the stream. Okay. So where are we going? I guess we need to initialize Vulkan.
No, let's create a window. Let's start by that.
Okay.
It's in SDL, yeah.
Uh, let me check the.
Yeah, just type in. It will help you. You know, autocomplete.
Okay.
So SDL
SDL
window.
window. Okay.
Yeah, pointer. Window. Yeah, and just say window.
Okay. Yeah. Oops. I'm
Yeah.
guessing I don't need to.
Yeah, that's good. Go on. And SDL
Yeah.
create window. And this needs to be it's incomplete, you know, so it's have to be a pointer.
It's a.
Yeah.
It's a pointer.
So here is the create window. Hold on.
Yeah.
It's not a class. It's you know it's a C library. Freak. CL create window. And here you see the tell. So go on. Tell
The
with height
title.
and flags. You see the documentation there.
Yeah. So let's say to the engine. Oops. And we need a say 800 by 600. Then
And
what
if you
is
want to
a
see all the
flag?
flags, then you could just say SDL window flags, you know. And then
There's flag.
control, and click on this.
Hmm.
And there you go.
So I'm guessing we need to use SDL window Vulkan.
Exactly.
Okay. Cool.
So just remove that now. No, just remove that. There you go. Now go on.
Yeah.
This is like
And
C
then,
enum, so you can just do it directly.
yeah.
There's no scoping. Do you want the window to
Okay.
be resizable? I think we don't want that right now, so we're not going to include the
Yeah,
hinge.
it doesn't matter.
Okay, we could check if the window is fine. Honestly, just assert, you know, you could say SDL assert that the window is not null.
Hmm.
I think it's probably just small, yeah.
But,
Hold on. There you go. Okay, cool.
yeah. So
That
window.
the window. Yeah, there you go. And semicolon.
Hey. Oh, it's just
Could be
saying
made
unused
pointer.
variable.
No, it said that that pointer could be made const. Doesn't because
Oh,
you're not changing it. So like if you right click on that,
yeah. Yeah, it will give you an option to.
exactly. So alt enter basically.
Yeah.
No, click no. Click there and alt enter.
Yeah. Alt enter.
Add
Oh,
const.
okay. Add const. Okay.
There you go. Magic.
Yeah, C
Okay.
line is a bit different.
Yeah. All right.
Yeah. Okay.
So this, I mean, you could try to run it. It's gonna pop out
I
real
did.
quick and go. Yeah, there you go. Now you have to make the
Yeah.
loop, the
Yeah.
game loop.
So wow. So we need a variable here.
I mean, you could go with that. Fine.
Yeah. Running. Running. So what do we need in the loop?
You have to loop like pull the events. So for
Oh yeah.
SDL event, just go on. Yeah, SDL event,
Event.
event. Yeah.
Is it?
No,
No.
event. So declared variable. You know, there. Event. So space event.
Oh.
And then
Oh, I see.
semicolon,
Okay.
yeah, SDL pull event. Okay, there you go.
Event. Okay,
And
what else
then
we need? Oh, the event.
an address to the event. Address to the event. So like ampersand.
Address.
Pointer.
Oh, I see the reference.
Yeah. So we need another loop here because like you want to like process all the events that are currently waiting on this
Yeah,
frame. Otherwise, you would only process one event at a frame. It's
yeah.
gonna suck. So it's like if you have a lot of input. Okay, and another semicolon. Just leave the other part empty. There you go.
Okay.
And let's see.
I'm
Condition is
guessing
always
here we need an
false.
if.
And switch better.
A switch. Okay.
And you don't need the open like float like what is it called, curly brackets, since you have a switch statement already.
Sure.
Yeah, there you go, and open the. Okay. You could also like
Yes.
hover over switch, alt enter, and then it would actually give you all the cases. Generate missing default case.
Yeah.
And okay, well, didn't give you that, but anyways, so go on.
And in the case the event was, is it
SDL.
a still quit?
They changed something about that though. I don't remember what was it. I'm pretty sure they've changed something. Well, hold on. If we go to SDL, yeah. Where is the docs migration? I remember they changed that name. It's been a while since I touched SDL. There you go. So you can see that they changed SDL quit to SDL events quit.
I see. Okay.
I'll
SDL.
remove the call. There you go.
There it is. Still event quit. In that case, running would be false.
The running should start as true.
Oh, yeah.
And I think in the newer C++, you could probably do something like this. I think, right? Hold on.
I
If I'm
think
not wrong.
so.
Nah, that doesn't seem like it. Though you could say 4. So there you go. Hold on, let me do something real quick. So if you go to settings and then like what is it called, clean actions or whatever. Oh, actions on save, yeah. You can reformat code.
Oh, yeah.
And now it's reformatted. Okay,
Nice.
cool. Lovely. All right, so what's next? So we have pull the events, we have the loop, and now what do you think we should do?
Well,
You
let's
can
see if
try
we
it.
have the window.
Yeah. Switch
Oh,
quantity, not an integer. Hmm?
scorched quantity is not an integer.
Oh yeah, event type, not the event itself. There you go. Okay, try now. And there you go.
Yeah,
You got your
maybe the
window.
Nice.
All right, let's go. All right. So now what we should do?
I'm thinking maybe like. I have actually no idea. That's the thing. I've
By the way,
gotten
this
this
could be
far.
exit success, but yeah.
Oh yeah.
Anyways, so I think let's start with Vulkan maybe.
Yeah.
Okay, so include Vulkan. I don't think I have the SDK. I have reset my system. But I can download it now.
Yeah,
Anyway, go
that's
on.
the thing. A hashtag isn't here.
Daniel All, welcome to live stream. How do I fix SDL.h not found? Nothing seems to work. You can rewatch the stream where the part where we actually have set up SDL. Because like to be able to use SDL as a library, you have to link it, you know, and to set it up in your project before you could use SDL in it, and before you can include SDL.h. Yeah, continue.
Do I need is Vulkan or is it
Yeah, you need
SDL?
SDL Vulkan and you need Vulkan.h. So, and by the way, Daniel, if you're using Visual Studio, you can watch my previous, like my latest video on that. It's pretty simple to set up in Visual Studio. If you're using CMake, then you can see one of the other CSDL videos I've made, or you could rewatch the stream. But yeah, it's Vulkan.h, Vulkan/Vulkan.h, I think.
Okay.
Hold on. Let me see. So it's CL3 slash Vulkan. What? No, I don't.
You put SD3.
Ah, I see. There you go. And then
Okay.
Vulkan.h. There you go.
Nice. Okay.
I've been using Visual Students always works. I've recently tried setting up with NeoVim, which I can't get to work. How you would set up Visual Studio with NeoVim? Okay, so we have included these. So SDL Vulkan
Yeah.
would give you the ability to Lloyd Vulkan. Though honestly, right now, I mean, the best way is to, of course, link Vulkan, you know, at runtime.
Mm-hmm.
Like using SDL. But let's just, I think, keep it simple maybe for now. What do you
Okay.
think? And let's just use Vulkan directly. So,
Yeah.
I mean, could go with Volk though. Yeah, let's go with Volk, honestly. Let's go with Volk.
What is
So,
Volk?
okay, let me see. Vulkan, what is it called? Vulkan Docs, I think it's called. What I'm doing. Oops. Okay, this one, I guess. And where was it? Good question. Let me search more. There you go. Okay, cool. So it's in Vulkan Loiter. Okay. So
Oh.
if you look here, it's gonna actually tells you why we need that. So there's dynamic linking, there's static linking to Vulkan Loiter. There you go. So why we have to do this? So basically you have here the Vulkan Loiter trampoline and the Loiter terminator, and then the drivers. So there's a loiter that is in between you in every single call, in every single Vulkan call.
Yeah.
But like after you do it right, correctly by actually loading Vulkan, you can actually remove these indirections from the call chain to Vulkan. And so you get like direct. So if there is no layers, then you basically call into the driver directly at some point, instead of going through the loiter every time, and then you have to redirect you. So it's better performance basically.
Mm.
So yeah, but like yeah, you could read through this more, and there's also this other stuff right here, but this is pretty cool. All right, so let's just go with Volk. Volk basically makes it easier. I mean, I could show you how to do it manually. I think I've done that before in my channel, actually a lot of times. But I'm just gonna
Yeah.
give you a little idea of how it's done in SDL.
Okay.
So you just say Lloyd Vulkan. Well, what is it called? Vulkan Lloyd library, yeah, like this. And here
Mm-hmm.
null for the null PTR for the path. And then, so this would basically go ahead, like SDL would, I think I could see the, well, I mean, I may be able to show what's happening here if I do this. So like, there you go. This is what SDL would do. It would go ahead and it would try to load the Vulkan library, dynamic
Yeah.
library. And there you go.
Okay.
But anyways, so after we load the Vulkan library, what we have to do, we have to, so like the first function that we can call is, let's just say we want to get the Vulkan version.
Mm-hmm.
So, oh fuck, I forgot. Yeah, enumeration version, yeah, I see. Can't tell I haven't touched Vulkan in a while. Instance version. All right. So here the API version. And now you enter the 2T API version. There you go.
Yeah.
Now you can, by the way, actually use this directly without the Lloyd library and stuff.
Yeah. Yeah.
Or is it? But you have, though, if you do that, you have to link to the system library
Yeah.
directly. So we're not doing that. Now we could just say like, well, we have to use a, hold on. We have to use a constant vk version, well, major.
Version major.
One of them is
Or API.
deprecated. It's probably the other one, yeah. This one is the right one to call. Actually, we could use a CD print. std my mouse keep on jumping.
My mouse is off the screen. It shouldn't do that.
What the heck? I think it's not
Is the
available.
IO?
I think it's not available
Yeah.
in this compiler.
Oh.
It's only available for now, I think, in MSVC maybe.
Oh.
That's
Okay.
why, unfortunately. Anyways, let's just go with printf, the old printf. No, okay. So vk API version major, API version, vk API version minor, and vk API version patch. Yeah,
Patch. Yeah.
there you go.
There's also variant, but it's not important.
Yeah. Variant comes first. Yeah. Okay. So as you can see in defined reference to vk enumerate instance version. Now what we could do though, we don't even need this, right? And so we don't need this either. Oh my god. Okay. And then what we could do, we could just come here and say Vulkan. So it would link to the system library
Okay.
directly. And we could do this. No such file or directory. Huh. Interesting. Do I have to install the SDK maybe? Yeah, I think so. Let me install the SDK real quick. So Vulkan SDK. Download the Vulkan SDK. Okay. Alrighty. You know, just next.
There's SDL 2 libraries.
Yeah, but this would include it in the Vulkan SDK. I mean, you could use that if
see.
you're using like Visual Studio, then you could basically use that path.
Yeah.
But anyways, hopefully it wouldn't require me to restart. And it also includes the Vulkan configurator and hardware capability viewer. Yeah, this one. There you go. So this one will tell you properties about your GPUs. So you could select your GPU here, and then you could see all the Vulkan properties of it. Interesting.
Yeah.
And here the Vulkan configurator, which you're gonna use for debugging Vulkan. There you go. So that's pretty cool. Now, since we can keep the Vulkan configurator running and make sure it's on validation, and then if you run, you should be getting Vulkan errors, but we haven't linked to Vulkan yet. Huh, it doesn't work still. Interesting. I'm not sure why. But anyways, let's just go with the way that I want to do, which is we're gonna use SDL Vulkan here. We're gonna load the library. And then the thing is, we also, since we're not going to be linking through the linker, we can define vk no prototypes. So it wouldn't include those functions that you can call directly. You see, right now this is invalid. Because since we're using this way of doing it, we have to actually load this guy, right? So auto interpret cast, well, pfn vk enumerate instance version, and then SDL get proc, I think Vulkan get rocket. Yeah, vk get instance proc addr, and then the function that we want to load from the library is this guy. Function is, but it's called with one argument. Oh, my bad. I see. So yeah, I just remembered. So this guy would actually give you a function in Vulkan. It's included in specification called vkget instance proc addr. Right, and then we can reinterpret cast that. Yeah. And then we're going to use this function that we have loaded from the library to load the other Vulkan functions.
Oh, I see.
So the instance would be null
VK
ptr
null, right?
because we don't have any
Oh.
instance yet. This is the global function because there's global functions, instance functions, and device functions, which you're going to see
Okay.
later. And here the name of the function we want to load, and in this case it's going to be vk enumerate instance version. And here I'm just reinterpret cast here, so cast it to the right type. And this could be made const. Same thing here. And there you go. Now we could run this. What's the warning? For function main ours return 0. And there you go. Nothing is. Okay, there you go.
There we go. Yeah, we had to finish it first.
So we got the Vulkan version. You
Okay,
see
well,
how it happened? So we loaded the Vulkan dynamic library using SDL.
Yeah.
So SDL is basically taking care of the cross-platform stuff, even the Vulkan library's name, because that changes from platform to platform. And the way you load the library also changes from platform to platform. So SDL takes care of that. And then we get the instance proc ADR, then we use that to load the other functions. Now let's actually do our first step in Vulkan, which is to, I forgot myself. You could do this now. So vacate. So we won't need enumerated instance version anymore. We want vacate create instance.
Okay.
So how would you do that? So replace vacate enumerate instance version with vacate create instance.
This one here.
Yeah, okay.
Okay. VK create instance.
Exactly.
Instance
There you go.
version.
No, just instance. No, just remove version, yeah. There you go. Now change the type of the function because, it's another function. It's have another signature. That's auto, but where's the type? It's in the reinterpret cast.
Yeah.
So PFN, so all the pointer function types starts with PFN, then vacate.
VK
create instance. There you go.
Okay.
Now we don't want enumerate instance version anymore. Remove that. And no. Remove these. Remove these lines. Remove that API version too. Yeah. And rename that variable to make it create instance.
Instance.
Same with the printf. Remove it. The printf down there.
Oh, yeah. So for this, instead of API version, we are using this.
No, just remove that printf. That's whole printf. Yeah. Okay. Now we're actually gonna call that function vacate create instance to create our Vulkan instance. Go on.
Ah, I see.
So, call. Now check out the signature, hold control and click on that. On the vacate create instance. No, on the call. There you go. But it didn't work. Interesting. You could press on PFN vacate create instance instead. Control and click on that. There you go. So that's the signature.
Yeah.
So it needs vacate create instance create info and then vacate allocation callbacks, and then it gives you an out variable to a vacate instance. You can notice that these other ones are constant. These are constant pointers, but the other one is not constant, so it's an out variable.
Okay.
So
a instance create info and allocation callback.
Yeah. So vacate, yeah. Well, it's It's big V, but
Is it this one?
I'm not sure why it's saying new, but like try it. Nah. Just say Vk instance create info, yeah?
Yeah.
And open that,
Okay.
like initialize that. It's a struct. I'm
Oh boy.
not a big fan of the way C++ initialize stuff. Like you have to just basically give it everything in. But yeah, go on. So the vk structure type. So say vk, it's a constant vk structure type.
Okay. Structure type.
So it's gonna be instance create info. Vk structure type instance create info.
Okay. Okay. Structure. Create.
Instance create info. There you go. It's right there.
Instance. Create info. Okay.
Now what's next? So this type basically is like later on you're gonna have like a next variable. Actually, it's right here. Yeah, you see that constant
Yeah,
void
it's
p
just P
next.
next.
You see that it's void pointer, right?
Yeah,
So
yeah.
it could be several types. And the thing is, when you have a void pointer, you cannot really know what's the type of that struct or
Yeah.
whatever that is. You cannot know the type. So that's why we have every single one of these structs. The first field is S type. So we have an
Okay.
enum to say which type it is. So when we use that p next, so like as a linked list kind of, you can know the type just by getting the first field. Of course, I'm
Okay.
talking about how the Vulkan library would work, but like the
Yeah.
driver would know. But anyways, so go on flags. Flags. Well, p next first, null ptr.
Well, what am I passing as P next?
Null ptr.
Oh no, sorry. Okay.
Flags.
Oh.
Flags 0.
Flags.
0.
Oh, as in okay. Yeah.
And then vk
Flag
application
0.
info.
P application info.
That's a pointer, so you have to create it out of that and then reference it. So go on,
Okay.
create vk application info struct.
So that's a pointer as well.
No, it should be just normal, and then you would reference it there.
Okay.
Just call it application info. So
Info. Okay.
reference.
Reference.
Enabled layer count.
You went the
0.
layer count.
We're not gonna enable any
What
layers.
is layer count?
If we wanna enable layers, we're just gonna use this Vulkan configurator. These are the layers. So like validation layer right here is gonna help us to like debug the Vulkan application,
I see.
the Vulkan API. And like there's another, hold on. There's another layer called API dump, like which can actually show us what functions we call into Vulkan, for example, what kind of parameters we're passing, what we're getting back, what time it took, etc.
Yeah.
There is also, if you remember here when I was talking, well, not here. Where is that thing? Yeah, there you go.
Oh yeah.
When I was talking about this stuff, you noticed that there's layers. So these layers comes, intercepts the function calls, right, to the driver. So
yeah.
And you could basically stack on top, like you can enable multiple of them at a time. So yeah.
Okay. Cool. And now.
So basically, you would enable the validation layer for debugging, and then you would disable it for release. But anyways,
yeah,
for performance, basically.
Yeah.
Enable layer named null PTR. We don't have any layers.
Okay. Null pointer. And the next one is enable the extension counts.
Okay, so we're gonna need some extensions. That for now just say 0, comma null PTR.
Okay. 0. And enable the extension names. That would be null pointer as well.
Yeah.
Okay.
Hold on a second. And yeah, here we're just gonna say vacation info. Yeah, and go. Now structure type, what you gonna do here? Yeah, I see. Allocator, just say null PTR.
Okay.
These basically you could set them to like the functions that you want the driver to use to allocate memory and deallocate, etc. But
Yeah.
null PTR for like the default.
Okay. And then this would be.
This would be the out pointer. This would give you back the instance because the return type, like the return of this function, would be the result.
Yeah.
Well, instance.
Oh wait.
Go on.
Instance? Isn't it this one?
No, like you would actually create like.
Oh, I see.
Then it would give you back that.
I see. Okay, instance.
No.
No. Instance.
There you go.
Okay. Why is there so many errors?
Good question. Because it creates info, it's expecting it to be a pointer. So we could do this.
Oh.
Right, and there you go. Though this would give you back a result. So a vacay result, which is going to be a vacay success, which is 0, or some warning, which is going to be a positive number, or a negative number, which is going to be an error. For now, I'm going to keep it simple. I'm just going to go with SDL as search. Not that, I guess. What about this?
Yeah, maybe.
So run. It wouldn't have any effect. We're just making sure that it runs. Okay, we have an error. Where's the error? API version is valid, which is not permitted. So because here we have the validation layer on, so it tells us an error. So we are using something wrong. What is what it said? Read the whole thing, like from.
Yeah.
Like you can see the first thing there.
So
where's the error?
Instance create info. Okay, this would be here.
And then look more. Look, continue on the error.
CSS API version has a value.
No, before
0,
that,
which
you have ignored it.
P application info API version.
You see now?
P application info.
Where's the application info that we have made?
The application.
It's right there.
Oh, this one?
There you go.
Oh, I
we
see.
haven't initialized it, yeah. So can you initialize that?
So this. Right. What do we need here?
Okay, there you go. So structure type. Just like before, but it would be different, yeah.
Structure. type, and this would be, I'm guessing application
Exactly.
info. There we go. The next one would be pnext. That would be probably polnoid.
Application name, you could just leave as null pointer, or you could call it something. Yeah.
The construct star. Okay. Let's say 2D.
Application version, you could say VK API version. Or you could make your own version. No, hold on. So like, hold on a second. You could basically say VK API version. You could use one of these versions that are already made, or you could make your own version. Whoops.
There's one extra bracket.
Oh, I see.
Yeah.
So VK make version, make probably API version because the other one is deprecated, and then it would give the variant and the other stuff. So
it was 1 point. Yeah.
The variant, the major and minor, and the patch of the version. But honestly, you could just keep this as 0. Gone.
Okay. And then the next one is
engine name.
Engine name.
Yeah. So you could call
what
the
is
engine.
The engine name?
The name of the engine. Like you could either call it null PTR or give it some name. And the API version, well, the engine version too, 0.
Engine version.
Or some other.
0.
API version. Here you would use that VK API version, the constant. Use the latest one, API version 1.3.
Yeah. Version 1.3.
And there you go.
That's
Control
it.
S. And there you go. You have no error. So, okay. Cool. So how would you check like which calls are being done? So go to the Vulkan configurator.
Oh, yeah, that's
exactly. Switch to API done. Now run this. Yeah, run this now.
Run it here or from
no,
here?
Run the, yeah, exactly. There you go.
Yeah. Ah. This is cool now. So we call the create. It gives us the memory address as well.
Yeah, so like you could use your debugger to check that on, check that out.
Damn, okay, that's cool. you can hear me sounding like a child.
Yeah, exactly.
It's like, ooh, cool. Next, allocator, VK instance. Okay,
it gives you the thread, it gives you the frame. You can see at top there. If you go to top there, it also gives you the thread, the frame, and then it gives you what it returns. So it returns VK results, VK success in the end there.
Yeah.
Yeah, there you go. So
interesting.
Now go back to the configurator. There's also some other stuff, but other than that, you could go to that drop-down menu up there. If you wanna switch here, actually not there. Hold on, where is it? Hold on.
You can take control.
Disabled by. How do I? Yeah, you could say layers controlled by the Vulkan applications. And now, like only the layers that are enabled by the application would be on. Hey Moody, welcome to the live stream. You see, so now there would be no layers on. Like it would be calling to driver directly. So you see how clever that is.
Yeah, that's actually pretty cool.
Yeah, let's. So whenever you're developing, you better keep the validation layer on. Unless if you're like checking performance, let's say, then you want it off.
Yeah.
or of course release, but anyways. All right, so what should we do next? So we have created an instance right now, a Vulkan instance. Now we have to basically choose a queue from, like, choose a device, actually, yeah. It's a lot of work, man. It's a lot of work.
Well, here's the question.
Yeah.
Is it possible with SDL to just display a texture on the screen
It is possible without Vulkan.
without Vulkan?
Because with Vulkan you need like around 1000 lines of code.
Oh, jeez.
Auto my eyes.
Auto my eyes. Listen, auto is good when the name of these variables is that long and that like your lines are gonna be like
Yeah.
2000 characters.
Anyways, let's just do it. So you just create vk physical device variable.
Okay.
It would be empty. So vk a big V. So the types are big
Yeah.
V, K. Yeah, physical device. No, it's just like vk instance. You know, up
Oh yeah,
there.
physical device.
No, like this. Hold on.
I see. Okay.
Gone.
Yeah. Okay.
Just make physical device, honestly.
Okay. Do we need to initialize anything here?
No, we're gonna initialize it using a function call.
Oh, okay.
So we're gonna remove this, and to actually call something, you have to load it, right? So you have to again do this, right? So and then vacate enumerate physical devices. You see?
Oh my god, this is a pain.
This is where vocal come in. So you do it like this. This big code base would be confusing. Exactly, yeah. And this is how you would actually like load another function. And then you have to use this.
Oh my god.
So here you would pass in the instance.
Yeah.
And then he would, like, when I just started Vulkan, I was like
count.
completely clueless. Like no one would actually explain to me any of this. That was crazy. Anyways, physical device count. So for the physical device counts, for now I'm just gonna hard code it to 1. And for the physical devices, so this is actually, you could use this to like get a list of physical devices, but right now I'm just basically hard coding it to 1 physical device. To keep it simple. Well, just like that, right? So this function would give us the physical device. Well, no, I mean, well, actually I have to do equal 1, right? So I want 1 physical device. And then it would put this on here, basically. And now I'm gonna have my physical device, basically. But you can see that this is a pain, right? So every time you have to load this crap and so on and so forth. So what we could do, we could use Vulk. So, oopsies, not this one. So this one. So a meta loader for the Vulkan API. Allows you to dynamically load entry points required to use Vulkan without linking to Vulkan-1.dll or statically linking Vulkan loader. Additionally, Vulkan simplifies the use of Vulkan extensions by automatically loading all associated entry points. Anyways, we're just gonna... Oh, wait, I have a CMake list now? I mean, yeah, I did have already. Anyway, never mind. Okay, so we're gonna actually add this as a submodule. I mean, you could do it yourself, fine.
Yeah.
Yeah.
Okay, where's the terminal?
Function that takes over dynamic Lloyd and Vulkan method would be easier. It's already there. It's get instance proc ADDR. So like first you use the SDL function to Lloyd that function, and then you use that from there. So okay, so you added that Vulk. Cool. Now you got to go to the CMake and link Vulk. Well, add it
it says
first and
warning. Warning in the working copy of .git module. LF will be replaced with CRLF.
I just ignore that. I don't know.
Okay.
CMake list. Adds the directory. So first of all, adds the directory. Yeah.
Directory. Submodules. That would be walk.
Exactly.
Yeah, there we go. And here, what is the namespace?
No, it would help you. There
Walk,
you go.
okay.
And go on. There you go.
Walk headers?
No. Actually, good question. We could check out the. I don't remember. What's the difference between both of them? So if we actually go here, I mean, we could just click here and we'll see what's happening there.
Or you could just put walk
yes.
normally
So
because it's an alias.
It would actually. Well, hold on. Actually, what? Yeah, it would only include the headers, but the other one would basically link it.
Static. That's a static library.
Yeah.
That's a dynamic. Yeah. Yeah. This should be fine.
So now we just load the CMake changes. And now go back to main.cpp. Go up top there. So instead of including Vulkan, you don't actually, well, yeah, and we don't need SDL Vulkan 2. And I think we also don't need Vacant prototypes. I may be wrong. And then we're gonna like include Vulk.h. Though let me make sure that's the case. If define Vulk.h and not define Vacant prototypes. No, I need to do that, yeah. And what about including Vulkan? I'm not sure if it would, but either way, this is actually required.
Okay.
I don't think we're gonna need this, and I'm not sure about this one, but we'll see. So we don't need this anymore. This one, I don't think we need that. And now pfn wiki create instance. We don't need that either. And now you can notice that this wiki create instance. What?
Goes to wall and SDL.
Why the heck it's in SDL?
Maybe because it's not built, it doesn't.
I mean, yeah, we could try it. Oh, there you go. I see. I remember this error. I remember this error. It sucks. Okay, gotcha. So I don't remember how I fixed it though. So basically, Vulk, for whichever reason, you cannot find Vulkan.h.
I see.
Right? So it's different path or some crap. Okay, hold on a second. Yeah, I remember I think I've made like a custom target because that didn't work for me. Or otherwise we could go with the Vulk headers instead. So, and then we would try this now. And define reference to vk create instance.
Yeah, it's right there.
But I think we need something else for a header only to work, if I remember. Yeah, define Vulkan implementation. So it would include the implementation here. And there you go. But we got a segmentation fault. Why that's the case? Because we haven't initialized Vulk yet, which would load the functions, you know.
Yeah.
So before we actually do any of that, we have to make sure to say Vulk initialize.
Another segmentation fault.
Oh. Well, that was unexpected. I think it includes Vulkan itself, right? So we don't need that one. Do we actually need iStream? We do, okay. Okay, so what's up with this? So let's make sure that this actually is working. Really?
Access memory.
Did I miss something? That's interesting. Let's try to debug this. And
What's this? Oh,
so we got an instance.
interesting.
Yeah, here.
It's called device count.
I mean, that should be fine. Huh. Well, let's do it the way that it's supposed to be. So how you're actually supposed to use it is you would first of all call it once to get the count.
Mm-hmm.
And then
And then call it again to get the
physical devices.
device. I see.
So you're supposed to basically say this. So of course, the first time to get the count, you have to pass in null PTR here.
No point. Yeah.
And then physical device, you have to allocate memory. Or you could hardcode it, in an array with a maximum value. So, well, I don't think there is a max, but anyways. So malloc physical device count times size of make physical device. And then you would call that again.
Yeah, but this time you're not passing a null pointer.
Exactly.
Yeah.
And they would use this physical device count that is here. But I don't think that's a problem.
Void pointer?
Actually, let's just say ocho. And then I'm gonna say, can I use a static cast here? I don't know.
Oh boy.
I guess.
I don't think you can static cast to a VK physical device pointer to a physical device pointer.
I mean, like this.
Yeah, I think. Oh yeah, that's yeah.
What? Is this maybe null? I'm probably missing something. Do I have the debugger on? Yes, I do. And there's no error whatsoever. Oh, my bad, I think. Gotcha. Oh, man. So after you load you make the instance, you have to load the instance. I haven't used Vulkan in a while, so I forgot. Oh, crap. Let's go.
Oh, so there's a Vulkan issue.
So after you create the instance, you have to load the instance functions because this one is an instance function. That's why it was, throwing a segmentation fault because this function was null PTR. We were calling a null pointer, right? Now this should work. There you go.
There we go.
And here we'll have the actual, I mean, if I just debug here, you could see the physical device count 1 in my case and one physical device. There you go.
Oh, okay.
But honestly, I'm not gonna overcomplicate things. I'm just gonna say that device count is 1.
Yeah.
And just take the first one.
Because we know it's 1. Yeah.
I mean, you would just almost always you would just use one physical device and it would be the first, Unless if you have some specific needs, you want to target, let's say, integrated GPU exactly, or a dedicated GPU or something like that. Or let's say you want to query all the information for all the GPUs, let's say, because there's functions for that, But we're not gonna go that deep, yeah.
If you want to make an engine that works with SLI and Crossfire.
Yeah, you could actually use multiple GPUs, though you would probably need another extension. But anyways, so physical device count 1, and then here you would get the physical device. But yeah, there's a whole process that you could do to pick and choose the physical devices and such, but we're not gonna go through that. It's already complex enough. So there you go. And you would always have to assert that this is, though you don't really have to in debug mode. I mean, you could just go with validation and then make sure that it would debug break. It would break on any error. And then whenever there's an error, even though you're not checking for the function if it failed, it would just break when it reaches that. Anyways. I think Vocaloid instance probably could fail, maybe? No, it cannot. Okay, cool. All right, anyways. So now we got the physical device. Next up, we need so we have the window, we have to create a surface, which is like an abstraction over the window for Vulkan. But to create the surface, the thing is about Vulkan, you could use it without windows, without any of this crap. Like you could use it headless, right? For compute, let's say, for servers, for example, or whatever. So to actually be able to use windows and so on, like to render, you have to a window, you have to include another extension. And so what I'm gonna do here, I'm gonna make this one. This extension is called vacay surface extension. There you go. VKHR surface extension name. But this should be an array, of course. Though I could just... It needs a pointer, though. Can I actually do in C? I don't think so. No. So, okay, sure. Let's do it. Oops. Okay, fine. Let's do this. So, oops. Extend extensions. Or I'll just call it extension anyways. I know we have only one extension now. And it doesn't have to be an array since there's one thing, you know. So just one element. And there you go. So this is basically, so instead of using the actual string, which you could easily get it wrong, you could use the constant. Or like the macro. Anyways.
Yeah.
Now, after you do this, you can actually use the, now Vulkan, what it does, it actually tries to load all the Vulkan extensions. If they're not be able to be loaded, it would just be null PTR. You would just segment fault, you know, when you try to call one of these functions. I mean, you could actually use a function to check which function, like extensions are actually available and such, but we're not going to go that deep. Okay, so let's try to create the surface. Oh crap, I don't remember.
Isn't it VK surface KHR?
Yes, but why it's not showing up here?
A small V?
No, it should be like this, but did I forget something else? Oh, my bad. I see. So the thing is about creating a surface, it depends on the platform. So there's like multiple functions, multiple Vulkan functions depending on the platform, right? So like if you're on Windows, you would actually go ahead and you would define. So before you include that, you would define Vulkan Win32, I think, or something. No, it's probably. Hold on, let me see. Yeah, Vulkan VK platform. There you go. So VK use platform. So one of these, right? So like, for example, Win32, you would actually go ahead, define this, and then you would get access to some new functions that are only available in Win32, right? And then you would go ahead and you would create surface, Win32 surface KHR. And then you would give it the instance, then vk, and you got the point. So depending on the platform, you would do this. But since we already have SDL.
Yeah, that's what I was thinking. SDL can take care of that for us.
Yeah. So we can include the, just to be safe, I'm going to include SDL after Vulk, because Vulk is including Vulkan. So SDL doesn't have to. And then we're going to include here SDL3 / SDL Vulkan.h. Right, and then here SDL Vulkan create surface.
Yeah.
And then here you give it the SDL window. We call that window, right? Oh, it be
afterwards.
Exactly. And it needs the instance that we have created, the Vulkan instance, and then allocation callbacks, null PTR.
And then the surface that we want to create.
Exactly, and then it would give us back at the surface. There you go. Okay. Doesn't like that it's constant for some reason. And SDL Vulkan create server. Now, of course, this could fail. And yeah, that should be it. Should create a surface, I think. Let's just see if this works. Okay, it works. Perfect.
Okay, nice.
So we have created a surface.
So essentially, if I'm understanding this correctly, you need a window, and then you put a surface on top of it, and then you
No, so like
essentially.
the surface is just the Vulkan abstraction for window. So
I
like
see.
when you're talking with the Vulkan API, you wouldn't have to care about is this like a window, a Win32
I
window
see.
handle or an XCB window handle or an X11 window
You would just
handle
call
or
the surface.
yeah, it would just create the surface. So just kind of like when we actually loaded the Vulkan function that basically, so after you load that, you just load everything through it. You don't go back to SDL to load the whole thing.
I see. Okay.
So it just becomes cross-platform essentially. So
Okay.
you see what I mean?
Yeah. Yeah.
All right. So of course you're gonna create a surface for every window that you're gonna use. So
Yeah.
okay.
Unless you're showing the same thing on multiple windows.
Yeah. So the last thing that what you said? Sorry, what you said?
I was like, you create multiple surfaces for each window, except if you want to show the same thing on multiple windows.
No, no. You
So you would
have
just reference the
any
same
window that
surface.
you have that you want to render to. Yeah, you have to create a surface for it.
Wait, can't you just reference that?
What do you mean by reference that?
Like mirror it essentially?
How? You like every window that you want to render to using Vulkan, you have to
Yeah.
create a surface for it.
Okay. I see.
So, yeah. Now the final thing in terms of initializing. Now there is another process like trying to find the perfect queue and such. Like if you go to the Vulkan capability viewer, caps viewer, you're gonna see some queue families, you know, and some
Yeah.
crap
Yeah.
like that. But let's not go that crazy. We're just gonna go with the first
Uh-huh.
queue. So this is like for multi-threading, you know. So like
Uh-huh.
Vulkan is highly multi-threaded. You could do it to do some crazy things
Yeah.
with insanely high performance. But we're just noobs. We're just gonna use the first queue family. We're not gonna
Yeah.
worry about that. But like, there's functions to like get information about the queue, so you can pick the perfect queues for your own
Yeah.
purpose and such, right? So the queue family is here, as you can see here. It supports graphics, compute, and transfer.
Yeah.
We're interested into graphics here.
Yeah.
And it also supports presentation, which is needed to actually be able to present to the surface, you know, present the rendering to
Okay.
the surface. So as long as the queue that you have these, the queue family have these,
Yeah.
you're good. So this queue family have 16 queues, but anyways, let's not go crazy over that. So yeah, I'm gonna skip over that part where you actually have to look for the perfect queue. I'm not gonna do that. We're just gonna say, well, not SDL, vk. What is it called? Da, 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 yeah, let's just go and create device directly. Yeah. So, okay. So, like, we found a physical device. Now we're creating the logical device.
I see. Okay.
So, logical device could be even like multiple physical devices.
Mm-hmm.
So, like, there's an extension that like you could actually use like multiple GPUs through
Yeah.
one device, through one logical device,
I see.
and
Yeah.
such. But anyways, so that's basically the logical entry point to Vulkan, to that
Yeah.
physical device or whatever. Anyways, so Vicky create device, what it needs. Good question. Let's remove these. Let's do this first, so we can get the signature. So, oh, one thing is you notice that it takes a while, like to pop out the documentation. I remember there was somehow to, yeah, there you go. 0 milliseconds. What about now? No, it's still,
Maybe it needs reloading.
no, I don't think it's probably another one. There you go. What about now? Okay, cool. Perfect. Because like those milliseconds
waiting
keeps
for
on
it.
piling up. Like,
Yeah.
make your device create info.
Well, we had
Okay.
creative.
An LPTR for allocation callbacks, as always. And then finally the device. And
physical device.
here now we're gonna say vk device create info. And you know, structure type, I think you got it right now.
Yeah. But didn't we have create info already?
Yes. But like we could, to avoid trouble, we could do this.
I see.
So yeah. Same thing here. But anyways, let's just go on. Structure type. Device. Create info. I think that's. Oh yeah, we need to do the others. So pnex null ptr.
Yeah.
Flags. Let's just go with 0 for now. Q create info count. I'm gonna go with 1 Q. PQ create infos. Q info. This is supposed to be an array, but we only have one Q info, so it could be just one element.
Yeah.
Enabled layer count 0. Enabled layer names null ptr. And enabled extension count. We're gonna need some extensions. For now, I'll just say 0. Null ptr. And vk physical device features. Null ptr. These for extra features that you may want from the GPU, though we don't need any of them. So Q info. Okay, you could do this one, I guess. Hold on, make it device.
Q info.
What?
Isn't it create Q info?
Ah, yes, exactly.
Yeah.
Yeah, go on.
No, this would be okay. The structure.
Let me zoom in a bit. Okay, cool.
Structure. Fine. Q. Oh wait, device Q.
All right.
Device create info, right?
Yep.
No, wait.
No.
Device Q create info.
Exactly. Yeah.
Okay.
Null
This
PTR.
one is null pointer. This one is- Oh, the flags, that would be 0. Q family index 1. P cube. No, Q count. That would be also 1. Q priorities.
That's gonna be an array, but since we have one Q, and by the way, we want the first Q, which is gonna be 0. I mean, you could go with 1, but no need. And Q priorities would be an array, but since we have one Q, we could just make it a float. So address of Q priority.
Q. Wait. How do I get the
You're
queue
gonna create
priority?
it. You're gonna create it as a variable and set it as a float. You know.
Ah, I see.
So float queue priority.
What?
No.
What? Queue priority. Okay, and
You can set it to whichever you want because we have only one queue. It doesn't matter what's the priority is. There's nothing to prioritize when you have only one thing.
okay,
So there you go.
and
Address of queue priority because it's an array. You know, it's supposed to be an array. But we have only one value. You could just give it the pointer to that one value.
yeah,
Address, you know?
adders.
No, reference. Yeah, go on.
Oh, reference. Yeah. Queue priority.
Semicolon, yeah. No, after.
Oh my god, it's lags sometimes. I'm like, okay.
So,
So
yeah.
get info pointer flag 0.
We don't need this, but hold on a second. Okay.
Oh, yeah. So much easier to read. Okay, and then
Create a vacate device. Yeah, cool. Now create a device there, vacate device, so you can, because that's undefined.
This one.
Yeah.
Okay. Device. Device. Am I missing something?
Yeah, good. Now just make sure to assert that the create device is successful.
This one, okay.
Copy that, yeah. And there you go.
Okay. So
Run.
wait, it's the reference. It returned this. Okay.
And you don't need to initialize this one because it would be initialized using the vacate
Yeah,
create device as long as it's
like,
successful, though.
yeah, like, but we have been told so many times that keep it initialized.
Nah, no need.
Okay. Right then, so that should still work.
Yeah.
Yeah. And what do we do with the device?
The device is like the finish touch like of initialization. Well, actually, no, I still have a Swapchain. Oh my god. I just remembered. Oh my, you still have a long, long road. So, so the device is the one that you're gonna use a lot. So this is like what you use to do all sorts of operations, draw, dispatch, whichever you call it. You name.
So what does draw do?
It would draw triangles.
Oh, okay. Well, let's draw a triangle.
Well, it's not that easy. We still need a swap chain. To create a swap chain, we need to create a command pipeline, command buffer, command.
Oh my god.
This is not OpenGL. Oh crap. Yeah. I probably accepted to coach you all this because I forgot what it takes to.
Well, what we can do, we can leave it here. Yeah. If you can push this to GitHub, and I can go and like work on it a bit.
Sure. You can.
Unless you can just zip it and send it to me. You don't have to push it to your GitHub.
Yeah, sure. We're gonna do it after the live is done. So
yeah. Right.
Okay.
So we created a device.
Are you still not tired?
No, I
All
can go
right,
for
good.
like another
So let's
hour.
go ahead and create a swap
Okay.
chain then. So swap chain though is like the surface. It's an extension. So
Okay.
and it's a device extension because like there's instance and device extensions.
Okay.
So what do you think we should do to activate that extension? It's a device extension.
Uh,
So the surface was an instance extension, but
yeah.
the swap chain is the counterpart of it that is the device extension. Where do we create the device?
We created the device here.
Yes, where's the info?
This.
Does that include extensions? Maybe we need to activate wrap. No?
This include extensions.
Yeah, there you go. So one there.
Yeah. Okay.
And then you would reference some variable that you make. In the P,
Enabled
exactly.
extension names. Yeah.
There you go, go ahead.
So do we need a list of all the extensions?
Yeah, but like we have only one extension, so it's fine. Just do it one variable.
Okay.
Like auto extension or whichever.
What?
Just call it whichever. It's just because like in like C, which gives us the ability to like reference something like a temporary. In C++ we cannot do that. So you have to make a variable, you know.
Let's just call this.
Device extension.
Is it needed to be reference?
I mean,
Const star const.
good question. Yeah.
It's a const star const.
Yeah.
It's reference. Okay. Okay.
And this needs to be initialized to the Swapchain extension. Go look at how I've done the other extension, and you may get an idea of how to do this. So there you go, extension. So what did I VKHR surface extension? There you go. Extension.
This.
Yeah. But now you don't want the surface, you want Swapchain extension.
Okay. Let's see. Okay. Swapchain. Is it object type Swapchain?
Go on, keep on typing. Name. There you go.
Name extension.
Yeah.
I see. Okay.
And there you
That's
go.
passed on here.
Just make sure this initializes correctly. Like, run it. There's no error, you're good.
Nice.
Cool. So yeah, now we need to create the swap chain. Swapchain.
Okay.
Yeah, try to guess this.
Let's see. Swap. Oh, there. KHR. Device. Create info. Oop. Create info. Wait, that needs to be passed as. This one is a null pointer. Swap chain. Am I just using device swap chain? Device extension, yeah.
No, that's. What do you think that would give you? It's like before, like with the other.
Oh, it will return something.
Yeah.
Okay. So that would be auto.
No, not auto, because it's not going to be initialized immediately.
So is it VK Swapchain?
The type starts with big V.
Oh,
Capital V, yeah. Swapchain HR.
okay. Swap.
Swapchain. Well, okay, go on.
Okay. That should be passed as a reference. What's your problem?
What do you think happened there? No, it's good, but there's something wrong otherwise.
Oh, it's a different info.
Exactly. So?
Oh man. This is insane.
We can scope
So
it, just like I've done before.
VK Swapchain create info KHR. It's probably not KHR though, is it?
It is.
Okay. So Swapchain info. Oh man, look at this thing. Like, are you serious?
You haven't seen the pipeline.
Okay, let's see. I can do this. K underscore.
You have to check the documentation for this.
I'm just gonna swap chain, create info KHR. Pnex is null pointer.
Okay, flags.
Flags. Oh boy.
0 is always.
Okay, 0. A surface. We have a surface.
So like every surface have its own swap chain, like can create its own swap chain.
What is min image count?
You gotta check the documentation for that, so you can learn how to check documentation.
Ugh, Jesus.
So copy that to Google, right? Copy the name of the structure.
This?
Yeah.
Let's see. Hey Google, help. Right then.
Click.
Okay, surface min image count. F. Okay. It's the minimum number of presentable images that are at least that many images. Interesting. Max image count.
Well, that's not too useful for someone who doesn't.
Yeah, that's not useful at all.
Yeah, because that's just a reference, you know. So it's for someone like me who knows, but like just don't remember. Yeah, you
I
know
have
the
another
WebGL
idea.
swap chain?
Mm-hmm.
Like when you say swap buffers.
Yeah.
Wait, go on what you were doing.
Let's see.
Let's get swap chain. Someone is pissed off.
Yeah, this is not helpful.
Yeah, hold on. I know somebody that is good. So youtube.com. Okay. What is it called? Yeah, so Vulkan Swapchain. I don't remember if this one is able. Is it like?
You can show the transcript and then search for it.
Yeah, it's Creative Commons. That's fine. Let's go. I'm just gonna show you some. We cannot like sit here through the whole thing, but this is the Swapchain images.
Okay. I see.
I need to find. So you acquire an image from the Swapchain. So the Swapchain is like just a list of images.
Mm-hmm.
And then you present that. You draw into that image, and then you present it. And
I
then
see.
it goes.
So essentially, it's.
So this is for screen sharing.
I'm guessing this is for like queuing frames.
Exactly. That's what a Swapchain is. It's a chain of images.
Okay, it's a frame queue.
Exactly.
Okay. That was so much easier to just.
So because like if you draw directly to the window, like to the buffer, it's gonna get like tearing, screen tearing.
Yeah.
Like vsync off.
Yeah.
So that's what vsync on is.
Yeah. Okay.
But there's like multiple types.
Yeah. Yeah, I knew about the like vsync and that like.
But like in like OpenGL here, you have way more control.
Yeah. Yeah, I assume so. Like.
Okay, cool. So this is immediate mode that he's going to show now. But this is not immediate. Hold on, watch. I'm not sure what immediate he's done to images there, but anyways. So FIFO. There you go, that's FIFO. So it's basically a queue, right?
First in, first out.
Exactly. So you could have, that's the minimum image count, sure. You remember? That's what it is. So that's the minimum image count that you're going to have in your queue.
Yeah, and minimum would be 1.
It depends on what you want. But like, I would just set it to 2. I mean, there is a way to actually like gather some information to pick a better match, but we're not going to do that. Actually, we have to do that anyways, yeah. Yep. But that's what FIFO is. I think you already got it.
Yeah,
Let me get another example. FIFO relaxed. And there's mailbox. But anyways, let's not go.
Yeah.
Let's not waste more time on this. So yeah, I think you got a way better idea now.
Yeah.
For what you're doing. So minimum image count, just say 2 for now.
Okay, 2.
And image format, vk format, constant. Exactly. Let's go ahead.
Format.
So here, like the format of the images, you could just go with RGB. I mean, here's the formats that are possible in my case. So if you go to the to here, you can see that actually, if you go to surface, let's go. So look at this. So there's a function to get the surface capabilities, And like the minimum you can get is 2. Max is 8 in my case.
I see.
And this is the present modes that are available for me. And this is the surface formats that I can pick. If I pick any other one, it's not going to work. It's going to fail to
I
create.
see.
So we can go with this one right here.
B8, G8. It's just a
sRGB, yeah.
sRGB. Yeah.
No, that's R8 sRGB. Only red channel.
Is that a... Oh, it would be R8 and G8 B8
A8.
sRGB. There we go. Oh,
A8
there's
too, I
A8 as
think.
well.
Yeah, A8 too.
Oh yeah, alpha channel.
Though it wouldn't work if you haven't made the window transparent. Like, but anyways. No, go ahead. Yeah. Go back. I mean, I'm telling you, you have to, like, even though this is alpha, but it still wouldn't work unless if you make the window transparent using the windowing API, which is SDL in our case. Just
this.
Side note. So, no, keep it.
Wait, alpha as well?
Yeah, it's like it doesn't work without alpha there.
Okay.
I'm telling you, the window itself wouldn't actually be transparent, even if it's alpha here. Unless if you make it transparent using the windowing API. Anyways, image color space.
Image color space does
sRGB nonlinear KHR.
Okay. So
VK sRGB. Yeah, there you go. Go ahead.
Okay. Linear KHR. Okay.
Yeah.
Where did the thing?
Do Control S.
Control S? Okay.
Maybe remove that comment. Do it again. Do a comma. Huh.
Nope. Is it Control Enter? No.
No, I'm not sure why it's.
Alt.
It's supposed to give you.
Yeah.
Anyways, image extent. Image array layers. So the image extent is like the width and the height of the image, which is basically going to be the width and the height of the window.
Oh yeah, 800 by 600.
And before you go to the next one, while you're at the image extent, what do you think would happen when the window gets resized?
Ooh, I see. So in that case,
no, keep it. I'm just asking you a question.
You're just making it so that I think about it. Well, isn't there a way to here?
But like even if you get the window width and height, it would like after it gets resized, it would be already like outdated.
I see.
So in your opinion, what should we do after that?
Well, I would say that when we resize the window, we kind of create a call to update this.
Yeah. So we basically destroy the current swap chain and create again.
Yeah.
With the new width and height.
Yeah.
Yeah, that's just something to keep in mind. Just go with 800, 600, yeah.
600. And then the next one is image usage.
Image array layers.
Oh yeah, image array layers.
This could be used for some things like, let's say, VR. Like it would have
I
two.
see.
You have two images
Yeah.
stacked on top of each
But
other.
for us, it would be just 0.
No, one. Can't be 0.
1? Okay.
We need one image.
Yeah. I just thought that 0 is.
I gotcha. Okay, what is the next one?
Image usage.
Control and click on the image usage flags. No, on the image usage flags.
This one?
Yep.
Okay. wiki flags.
Go up.
Oh, jeez. Okay, samples. Attachment.
I think you probably want color attachment bit.
Color attachment, okay. Spaces here.
Because we're gonna render into it. So
Yeah.
anyways.
And the next one.
This
Image
is
sharing mode.
basically depends on like the queues, but we only have one queue, so it doesn't matter. Just say exclusive.
Yeah. Exclusive, so 0.
Yeah. But just say
Now,
exclusive. Use the constant, yeah. There you
oops.
go. Control S.
Wait. Okay. And the next one.
Key family
Sharing
index
mode.
count. Well, 1. That's like
1,
how
okay.
much queues. And then how much indices? Oh, like the indices array, which we're gonna have only one. So we could just reference a variable that is uint32t that's equal to 0 because that's the queue that we've initialized.
Yeah. T. What was it called? Family
Index, key family index, but yeah, whatever. Just go on.
index. That would be just 1?
0. The
Oh, 0.
first queue, yeah. But like reference it because that's supposed to be an array, but we have one element. Yeah, there you go. Go on.
Okay.
Pre-transform. Check that out.
Transform.
And just go with the identity bit.
Okay. Oh, is it for rotating it?
Yeah, for like phones, you know.
Yeah, I see.
Composite alpha. This is also something you have to configure for transparency if you want transparency in the window. But we're just gonna go with opaque, yeah.
Okay.
You don't need transparency.
Oh boy, this is getting long. Okay.
You have to see the pipeline.
Okay. Then present mode. Immediate cache, or I'm guessing. Ooh, FIFO. I'm thinking FIFO.
Yeah, go with FIFO. Present,
Yeah.
no, take the constant, not the number.
Yeah. What's there? Clipped.
Too useful.
Yeah. Well, I'm guessing clipped would be false.
No, check the documentation.
Okay.
Check the reference, I mean, in the, in the browser.
Yeah, yeah. What's there? It's possible to Vulkan implementation not to discourse rendering operations that affect regions of the surface that are not visible. Yeah, that would be actually true.
Yeah.
Yeah, okay. Select. Oh. Okay. Sense mode. Wait. Hello?
We've done it. We've done it before the present mode. Just Control Z, yeah. And do true after. No, cancel. And do, no, look in the next line.
Oh, I see. You see this formatting thing?
Yeah.
It's tripping me. Old Swapchain. Ah.
Null PTR. We don't have a null Swapchain here.
So I'm guessing here, if we had another Swapchain, we would just pass it in here.
Yep.
So that when it updates. Okay,
yep.
I see.
But you have a problem with create info.
Oh boy.
Swapchain.
Yeah. This
There you
here.
go. SDL search.
Oh yeah, SDL search as well. If this works. Oh. It didn't.
Hold on, let me see. Hold on, go to the console. Sorry. Go to the console. Okay, what's the error there?
Validation error. Look at this thing. Surface invalid. What?
Invalid Wiki surface object. Get so it said that the surface parameter is invalid. Maybe check that out.
Surface parameters invalid. Okay.
It's in the swapchain info.
Swapchain info.
Yeah. So the surface that you have passed for whatever reason, it's invalid. Huh. Hold on a second. Hmm. Interesting. Where do we create the surface? Here. There's one thing that I don't wanna, like, that could be tripping me. Which is the fact that if somehow SDL and Vulk loaded different libraries. Somehow. Just to make sure that's not the case. I don't think it is the case, honestly, but just to make sure. We're gonna be using SDL to actually do the job, and then we're gonna tell Vulk to use that.
I see, okay.
So we're gonna say SDL Vulkan Lloyd library. Null PTR. And then here, instead of Vulk initialize, we're gonna say Vulk initialize custom.
And use the SDL.
Yeah, but I need to see the signature. And here it needs the handler, which is going to be SDL, Vulkan, get proc, well, get Vk instance proc ATL. Yeah, I think I need to reinterpret Castus or something. Probably need to reinterpret Castus. Oops, hold on. Actually, let's do it like this. Oh, I can static cast? Are you sure about that? I don't think so. There you go. You see what I've
Okay.
done there?
Yeah, but I don't understand.
It's just like before, but like before we used Vulk. But Vulk is the
Uh-huh.
one that is loading the function pointers.
Okay, I see.
Let's see if that fixed it, hopefully. No, it didn't. I'm gonna have some fun time now.
Surface invalid object.
Interesting. Uh.
I mean, it's not
Problem.
null pointer.
No, it's not. It's invalid. You know what? Just to make sure.
What does that do? The
Oh.
be creating for surfaces.
What? Required handle. But why? I mean, it should do it here. I mean, if we do this, is the surface really null? Yes, it is. But why
Oh,
didn't fail? And in fact, even if it fails, why?
well.
Create surface, check window magic. You see what SDL is doing? Here's the Vaki create
Yeah.
132 service gate char.
Yeah, yeah.
Oh. What? It couldn't find create 132 service gate char.
Great. Didn't we
Interesting.
create that?
Nah, it didn't find this loaded. Somehow this is not loaded. It failed to load
Oh.
this one. And it's actually set to the error in SDL, but we're not checking the SDL error, so.
Mm-hmm.
Extension is not enabled in the Vulkan instance. Are you sure about that? We have enabled it. Here's the extension. Really? Oh. Well, no. That's for the device. Weird.
Is it possible that you have to pass in multiple extension?
Hmm?
Is it
Yeah,
possible
it
that you have
is.
to
It
pass in
is.
multiple extension?
It is.
Or maybe it's looking for it. in the create info.
What do you mean? I'm
Like
passing the
here,
extension
like
here.
oh,
Actually, hold on a second. API dump. Just to make sure I'm not tripping. Well, actually, no. There you go. So the extension names VKHR surface. Ah, I remember now. So you see, that didn't work because it like you have to enable the surface extension, but you also have to enable the surface extension of the platform.
Yeah, the Vin32.
Yeah, exactly.
Yeah, that's what I meant. That don't you have to pass in multiple?
Yeah, that's what I'm gonna do now. Hold on.
Oh, yeah.
So extensions, VKHR service extension name. In this case, it's gonna be VKHR
Vin32. Yeah. Extension.
Huh. Ah, but it's not gonna be here because it's maybe not defined. Either way, this is not even what we have to do. What we actually have to do, we have to rely on SDL to do that for us, basically. So let's see how we can do that. SDL, Vulkan, get extensions. Well, oh my god. There you go.
Oh.
And here it would give you the count of the extensions.
Oh, and you have to get the count.
Yep. And then, yeah, I actually have worked on this function on SDL. Like, I've committed the because before you had to actually allocate memory to get back the instance extension, but now after my commit, you actually just get the static array directly. So you get the count and you get the array, which is nice. So like you just say extensions, just like this. Very simple. No malloc, no crap like that. And now I can say this and this. Oh, maybe we have to. Ah, I see. Char const. There you go.
Okay.
That's simple. Let's go. Even in GFW, you have to allocate memory. And actually, is it? Maybe not. I don't remember. Anyways, whatever. Let's try this now. This should work now. But let's. Yeah, it's probably wrong. So for SDL, gotta be like this. That's why it tripped us. And we don't need that anymore. There you go.
Oh, interesting.
It works.
Okay.
So we're creating the Swapchain now. Swapchain. One thing that we could do, choose, get the vacant surface capabilities here that you've seen in the capability viewer. But like right now, we're gonna do it programmatically.
Yeah.
Because like you can't see the caps viewer in the user's machine. So
Yeah.
Capability, well, surface capabilities. And then you have to use a function. So I think enumerator get, I'm not sure. Let's just say surface capabilities. There you go.
Yeah. Get physical device surface capability.
So you give it the physical device and the surface, and then it gives you back the surface capabilities, because the capabilities depends on both.
Yeah.
And of course, we do this. And there you go.
Mm.
Now we could use, so this surface capabilities contains some stuff like a minimum count, max, count extent. So what we could do now.
Oh, interesting. So you can use this.
Yep.
Instead of these numbers, I see.
Though I'd rather say +1. No.
Oh, is it because?
Oops. There's like, for example, in AMD, there's a driver that would tell you 1, but if you said 1, it would crash, or I don't remember what happened. But either way, they recommend to do +1, so minimum image counts +1. Here, instead of that, we could just say now surface capabilities. Oops. Current extent dot width.
Yeah.
Dot height, and there you go.
Oh.
Okay. All right. So we also gotta get the images from the Swapchain. So to do that, we have to say vacay var images. And now get Swapchain images, I think. There you go. So you give it a device, you give it the Swapchain that you're talking about, and it would give you back the image count. So notice that this is actually just the minimum.
Yeah.
But the driver is like, can choose whichever. This is just the minimum.
Yeah.
So you still have to get the images count from the driver.
I see. Okay.
So image count. Well, let's just call it image count, right? And here no PTR.
UN32 is a bit too big for image count.
What do you mean? It's what it takes, basically.
I know, but like in
gotcha,
general,
yeah. I understand what you mean. But that's the API.
Yeah.
So, all right. Then. Yeah, so we're gonna basically copy this.
Yeah.
But we have to alloc though. So it's gonna be vacay image. Well, let's just say auto images is equal to interpret. Well, is it? Maybe static hash should be fine. And oh, actually, yeah, I forgot that I'm in C++. New vacay image. Well, I forgot completely that I'm in C++. So, well, actually, can you do this in C++? I forgot. Right?
I think so. Yeah.
Well, it's never used. Okay, cool.
Yeah, that's just.
And now we're just gonna give it the images. There you go.
Yeah.
Forgot completely that I'm working with C++. Anyways, so what's up now? So we got the images, and now we gotta create image views on top of these images.
You have to create the images on top of the images?
Yeah, so like the
I
images
see.
themselves are like raw, but to actually be able to render to them, like later on we're gonna create the pipeline and render pass and crap like that. To be able to render, you have to use the image view.
Oh, jeez.
So we could use the help of Copilot honestly at this point. So I'm not sure if I have extensions plugins. What is it called?
GitHub Copilot.
Oh my god. Let me show you what Copilot could do for this. Because this is mostly boilerplate, as you can see.
Yeah, it is.
I have to restart the IDE.
Wait, there's a specific Boolean type for Vulkan?
Ah, there's Vicky True, but it's pretty much just
Yeah.
0 and 1, I think. Yeah, there's like Vicky True and Vicky False.
Yeah.
But look at that. Look at Copilot.
Perfect.
Magic. There
wow.
you go.
Just put that there. Okay, what is this one doing? So, image view create info. Wiki.
What the heck? Why would I add it to CMake project?
What you say?
I don't know. Mhm.
Okay, and then
see.
create image. Okay.
So anyways, so we have a loop image count, so image view info, and all that crap. And now images I, type 2D, sRGB, swizzle identity. Nothing crazy there.
Yeah.
So it just creates an image view for each image, and
Use auto.
okay. We could use a unique PTR here, but like, is it really even? Well, I can use a vector though, right? And I feel my brain is like going from C99 to C++11 to C++.
Yeah.
Oh crap. Yeah, like how would you do it again? Crap. A CD vector? Yeah, it's probably a CD vector.
What do you want to do?
So like you would say, I think a CD vector.
Yeah.
I don't think you can use an array. That needs to be compile time. Yeah.
You need to give it type. Vector of type.
It may be able to get itself now.
No, you have to.
So this is not Rust.
Yeah, it's not.
Class template argument deduction failed.
Yeah.
So Wiki image view.
Yeah, there we go.
I don't think it's the same thing as this. Or actually it is.
Yeah.
Okay, cool. So here the like image count. I see.
Yeah.
All right, I just remembered that I'm using C++ now. Okay, cool. All right.
And that you would use at
Hmm?
instead of that C style.
No need, I guess.
This one.
Or is it? No need. I mean,
When
we
you
already
use
guarantee
C
that.
style.
We're already guaranteed that the size is fine.
True.
At would like check for every single one of them, but yeah. Anyways, so what's next? And this one could be this. All right, so image views. You have to create a command pool.
What the hell's a command pool?
It's the one that we use to allocate command buffers.
Oh.
It's kind of like if you know arena allocators.
Okay.
So like you allocate multiple things very fast,
Yeah.
but then you deallocate
Yeah.
everything at once.
I see. Yeah.
So
Like
that's
oh yeah, like arena and pool. I see.
yeah, pretty much. Now we can create a command buffer. From that, like we can allocate a command buffer. Yeah, it's going to be a primary command buffer, one command buffer. There you go. Image available semaphore. Now synchronization. Oh my god, I hate that. well. Yeah, okay, fine. Semaphore info. Okay.
Semaphore.
All right. What's next? So we have made the synchronization primitives. Now I think we have to go to rendering. We're not going to render anything yet because we don't have a pipeline. We don't have shaders and stuff like that. That's another story. But I'm going to try, hopefully today, we could just like at least clear the window with some color.
Yeah.
So we don't actually need, in fact, we don't even need image views for that. Like we don't even need this for that.
Okay.
The image views, we're going to need it for rendering for the actual.
Yeah.
And other than that, so honestly, just to keep it like straight to the point, I'm going to remove this for now until we want it later. And the other thing now that we're going to need, all right. So one thing that we're going to have to do is, where do we create the Swapchain? Oh, there you go. Where is the, yeah. So here we're saying color attachment bit. We're going to use a transfer operation instead. We're not going to render yet. We're just going to use a transfer operation to clear the image. So we're going to say transfer DST bit instead. Other than that, what we're going to, yeah. Can I make sure that the command buffer is resettable? Let's see, pnex command pool. Well, it has to be here, yeah. So here, if you check the command, what I'm doing. Yeah, flags here. So there is this reset command buffer bit, so I could reset it every frame and re-record. Though, I mean, I could just record it once. Yeah, I think so. All right, sure, fine, why not? So let's clear the screen. Perfect. Perfect. Oh, I have, so like if I want to, and I see. Like if you want to pre-record everything, I have to like make a separate command buffer for every single image. But I can, otherwise I can just re-record the same image using one command buffer in the loop. What do you think?
To be honest, I don't know where this is going, but
well, let's go with the pre-baked way, I guess. It's supposed to be the fastest because you're doing less work every frame. But we're gonna have to change it anyway, like in the next time. But why not? Okay. But to do that, we have to allocate command buffers. Command buffer count. So instead of 1, we're gonna go with image count.
Oh, I see. So each image that gets
Let's
kind
see
of
if the
put in
AI
a
would pick
queue,
up on
you would have a
that.
different command.
There you go. It picked up on that. Look at that.
Damn. Oh my god.
Horrible big info can be made context per. Oh my god. So we begin the command buffer, we begin recording. It creates a barrier for like, so the image starts as an undefined layout, so we have to switch the layout to DSC optimal, like to transfer DSC optimal, because we're going to transfer, we're going to use a transfer operation on the image, and we want it to be the best, in the best layout possible for that operation. So key family ignored, images I, aspect color bit. Okay, cool. VKCMD pipeline, here we're doing the synchronization. It's another story. That's synchronization. VK pipeline. But basically we go from top of pipe, so the start of the pipeline, to the transfer, because we want a transfer operation. This could be made const expert. This is the clear color. Sub resource range, not important for us right now. VKCMD clear color image. Here's the operation. Here's the
actual putting colors on the
so this is the actual operation that you're gonna submit to the GPU. So like here we created the command buffer, where basically where we're gonna record commands to the GPU, and all the functions that serve with VKCMD is a command. So there you go. Barrier 2 for synchronization again, because right now we're about to, well, hold on. Barrier. VK pipeline stage. So from the stage transfer bit, because that's the source operation, to the the bottom pipe bit, so the last of the pipeline. So because we're not going to be waiting for anything else, but like we're not going to do anything after it. But anyways, VK end command buffer, and finally we end the command buffer's recording, and then we have the wait stages. Color attachment output bit. So we're gonna wait for it to. I don't think that's true. That's correct. But anyways, submit info, image available semaphore, wait stages, and command buffer. Blah blah blah. So here we're basically gonna signal the render finished semaphore when this command buffer is executed properly. So here VKQ submit. Q, what's up with this guy? Oh yeah, we didn't get the Q. So like, let's go back. So after we create the device, we can get the Q. So vk get Q. Well, actually it doesn't give an error. So it's the queue family index, and the queue index then is going to give you, oh well, it's going to give you the queue like this, right? All right, T. So this is going to be like just big queue. Right, exactly. Well, there you go.
Yeah.
The queue is like the one that you use to submit command buffers to, so they can be executed through by the GPU basically. Here the fence, if you want some fence to wait on, and there you go. So after this commands are run, it's gonna signal this render finish semaphore, because like when this VKQ submit is finished, like it returns immediately. It doesn't wait for the commands to finish. So it's asynchronous basically. All right, cool. I'm just seeing if I'm making all this correctly. I think they should have their own semaphores. Yeah, exactly. All right, sure. So this should actually be an array then. Hold on a second. This is not an array either? Bruh. You see, the AI doesn't really like correct your mistake, it just goes with it. Ah, no. So here's the deal. So this is going to be like an SCD vector. And then we're going to say image count. And what's up with this guy? I cannot resolve, yeah. No. So just say command buffers. Dot data. There you go. And then here we're gonna need other vectors. So well, a CD vector, right? So oops. Dot data. See how much work it is?
Okay, while you're doing that, sorry. Just gonna do a stop control so that it doesn't jump.
Okay. So the command buffer would be that. There you go. Now for the fence. Do I want to wait for it? Good question. I think so. And oh, my bad. What I'm doing, I need to do a loop here. Okay, there you go. And in fact, I'm gonna also add fences. Well, not just normal fences. Not semaphore info, of course. If it's info.
It knew exactly what you want.
Yeah. Make a fence create signal bit. Now. Okay, so now we have to. Let's see if it's gonna guess it. No. Well, I mean, not bad. And also, I should have probably did it that way to keep it simple, but yeah, okay. So I'm waiting for all the rendering to happen for all the images before I go to the main loop. And then here, hopefully I won't have to type much now. There you go. Come on. Oh, why the heck it did that? No
We already
need.
done that. Yeah.
And now what? So we got. Actually, we don't need the render finished. Like, bro, what? No, we only need the image acquired semaphore. I mean, image available semaphore, yeah. And why the. What? Nah, bro, I'm super confused. Image available semaphore. No, what I'm doing. Yeah, it's fine like that. Well, actually, here's the deal. So I'm just gonna reuse one of the semaphores here,
Okay.
and then, well, semaphore like this. My brain is fried right now.
Yeah, it's
Vacay president. Yeah, that wouldn't work in C++, I think. Yeah, for sure it wouldn't. So, okay. Alright. Vacay queue present info. What? Really? Oh, what? It should be. Bro, what the fuck? Ah, there you go. P wait semaphores. No, only wait on this guy.
Swapchain.
Maybe that's it. If I didn't miss anything again. Let's see. Okay, what if I change the color? Red. And it's in p-weight semaphores. AKQ submit. Render finished. Waiting. Ah, I see. No, we're not waiting for anything here.
Hey, no errors.
It's blocked.
Can just stop it.
I'm not sure why.
Seems like it's not the for loop isn't looping.
Does it at least reach this point? It does?
Yeah.
I think after this point. Ah, because we're not seeing any fence. Makes sense. Righty. Maybe it should work now. Finally, we still have some weird errors, but it works. You need the Vk render path. Yeah, you do need that, but you need that for rendering. Here I'm just using a transfer operation called Vk cmd clear color image. Because if you want it to render, it's it can stay here forever. It needs another chapter. You're gonna need the render paths, you're gonna need the frame buffers, you're gonna need the pipeline, and all sorts of craziness. So this is, I guess, a good start. So VK corners not have any. Oh yeah, I think that was it for the stream.
Cool.
How did you find Vulkan?
I find Vulkan interesting, yet mind-boggling.
Just a lot of worry, man.
Yeah.
A lot of boilerplate.
I feel like I feel like you have to set up Vulkan once and just use it for all of your projects rather than every time.
Yeah, there is frameworks right there. I think there's libraries and stuff like that.
Yeah.
That could make it easier.
Yeah.
But honestly, I don't really recommend using Vulkan unless if you really need Vulkan. So, like, I would recommend instead WGPU.
Oh yeah. I've heard about WGPU.
WGPU Portal Graphics. It's actually made in Rust. It's implemented in Rust.
Yeah.
And it's actually using like DirectX 12 or OpenGL or WebGPU or WebGL or Vulkan, depending on which platform and what's available you see.
Yeah.
It's not going to be as performance as a good Vulkan, like as a well-crafted Vulkan application, but It's
Yeah, I don't think I would be able to create a well-crafted Vulkan application.
Yeah. That's the thing. Or they were just using like one queue and yeah.
Yeah. All right.
So that was
Cheers.
a crazy adventure.
Do send me the zip file.
I think
I
I'm just
can.
gonna like make it into a GitHub repo right now, honestly.
Okay.
Let's see. Add to VCS. Interesting. Hold on. We need a dot git ignore. And then
The bin folder.
CMake both debug in this case. Okay. And now mask. No. There you go. Okay. Can I add these? There you go. Branches have diverged and it's pushed. Well, actually, let's go to. Can I view the code later? Yeah, it's actually landed like launching on GitHub. Okay, let's see. Let's actually do a license though, but yeah, we can do it there. Okay, hold on. Oh. All right, so I'm gonna stop the screen share.
Yeah. Sure. Man, he didn't let us watch his password.
Okay, it's successfully authorized. Let's share. I made it private, but I can turn it to public, so. Let's make it public. Danger zone. Okay, let's go back to save zone. And now, let's create a new file. Oh crap, license. I honestly do not understand crap in licenses. I just go with Almighty.
What will happen if your code doesn't have a license?
Some people wouldn't use it.
Oh.
It's in the danger zone.
It's in the danger zone.
So yeah, here's the link.
All right. Cheers.
Yeah, that was it for the stream. Any questions? Any last questions?
No, to be honest, I am overwhelmed a bit.
So a lot of questions.
Yeah, like I think I have to go and read through the documentation, but if like anything doesn't make sense currently,
I see.
I'm not gonna bother you with that. Oh,
So yeah, that was it,
right.
guys, for the stream. Thank you for tuning in. Thanks for
Yeah.
viewers. Actually,
Thank you so much for helping.
yeah. So, thanks to Theo Paris, Baron Moose, Roji Kirin, Daniel All, Moody, and me.
Yeah,
Okay.
thanks to you.
See you guys. Thank you. Bye.